Hi everyone, welcome to this session on VLSI careers, roles, jobs, opportunities, and futures. We'll have an overview of all these areas where we'll talk about what are the careers in VLSI, what are the roles, jobs, what are the opportunities. And I know we are going through a slowdown, so a lot of people will have questions. So if you have any questions, please type it in the chat window, and I'll take those questions as well during the webinar. So let's get started. This is about me. I am Vikas Sachdeva. I am IIT Delhi graduate. I have more than 20 years of experience in EDA and VLSI. I'm passionate about talent development, motivating people, and I've been working in VLSI field and motivating people to join this field. I also have a book, which is a best-selling book on Amazon. It's called "Become Irreplaceable." So if you're interested, as in go search out for those books. This book talks about 7 ingredients which can help you save your job from AI invasion. So please do check it out. It's already a bestseller on Amazon. So let's get started. Let's start talking about VLSI and the field. What are the opportunities here? Okay. So what is a chip design, right? And most of the people who are from engineering background, electrical engineering background know that chip design is not A, this is B, which is the symbol for a chip, and this is chip design. And what is inside a chip actually? Has anyone ever seen? So this video shows, as in very short video, how minute these devices are, which we are developing on a chip, which exists on your cell phone. Let's see what is inside a chip. So this is scanned using a scanned electron microscope. So this is how small these devices are. And this is from a few generation old technology, and we're talking about a technology which is even smaller. We are hitting 2 nanometer, 3 nanometer range. We probably have just a maybe couple more or maybe three more generations left before we can't scale any further lower down in the technology. So this is how small these devices are. Okay. So I think a lot of people would have talked to you that it's very difficult and complicated to make these devices, but that's not the case. These technology nodes that we talk about are basically very small. 2 nanometer, as I said, right, is the latest technology node, and we are going much further in down in the technology. But probably we'll have just one more or maybe a few more technology node we can go down to, unless we change the kind of devices we are using. So the why this is important, right? Almost everything you use today will have a chip or a semiconductor device inside it. Your everyday use washing machine, that is a chip. There is a chip inside that. All the medical equipments, or most of the medical equipments, have that. Aeroplanes have that. Your, of course, your computers and TV consoles that you are using have that. Cars is something which have that. Refrigerators, smartphones, TV, all these devices, all these things that you use, which you see across, have chips or semiconductor devices in that. It's actually, there were more than 1 trillion chips that were shipped globally just in the year 2020 itself. So you can see it's a huge market, and that's why there are a lot of huge demand and huge, very big companies, even startups and small companies working on it. What is the ecosystem for these chip development? So you would see, like, you will hear about something known as fabless companies, companies that design and sell chips, but they don't manufacture it. So they don't convert that into silicon. They basically design those chips, and then it's given to a foundry, something known as a foundry, for manufacturing. Like some of these companies are like AMD, Nvidia, Qualcomm. Then you have foundries, companies that manufacture chips. These manufacture chips typically for a fabless company. Fabless company don't manufacture it, don't convert it into silicon, but give some format which can be converted into silicon. Like you have TSMC, Global Foundries. Then there is something known as OSATs. It's basically outsourced semiconductor assembly and test. So basically, it's semiconductor assembly and test, which is outsourced. These companies that assemble, test, and package chips, typically for fabless companies and for devices or electronics company. Like there is ASE Group, there is Amcar Technologies. Then there is something known as integrated device manufacturers. These companies not only design like fabless companies, they also manufacture like foundries. So basically, it's kind of combined of fabless plus foundries, and then sell their own chips. Some of these typical known companies are Intel is one of the companies which has both design and fabs, and then they sell chips. NXP is one such company. There is Analog Devices. Then there is supplier, right? The companies that supply material, equipments to create those chips. One of that is ASML. This you might have heard about. One of the most important companies, which basically for lower technology nodes provides equipment. Then there is Applied Materials, which provides materials for semiconductor. So this is the ecosystem. You have fabless companies, you have foundries, you have OSATs, and you have integrated device manufacturers. Then there are suppliers. All these make the semiconductor ecosystem. So there are a lot of companies in each of these ecosystems. Some of like the biggest companies, Nvidia is probably the biggest VLSI company right now. It's a fabless company. So what is the future of this chip technology? First, there is a chip market boom. There is increasing device consumption that is coming up, that is going on. 2019 it was 450 billion market. By 2030 it's forecasted to be $1 trillion market, and it's you can see it's growing at a very fast rate. So that's the future. There are new industries which are coming up, or there are older industries where more and more semiconductor devices are being used. There is 5G technology and now 6D technology which is coming up, cloud computing which you use every day, artificial intelligence, chat GPT, Bard. You would be hearing about this every day. Smart cities, your even smart homes, smart cars, electric cars, and multiple others. So there is a growing demand not only in the existing markets. There are new markets which are coming up, new industry requirements which are coming up, and even older industry which are basically growing up to use more and more electronics. For example, cars are a prime examples. Even the scooters, Ola scooters which are sold today, has a lot of semiconductor and chips within that. So India is basically at a position because of multiple reasons, because of geopolitical situation, because of the government is at a situation where it can make best use of semiconductor, best use of electronics industry, and government is really motivated to do it. We have various geopolitical situations in our favor, so this is the best time for us Indians to join this industry and do something in this industry. Okay. So I believe, right, as in India has a very immense amount of youth capital. There are a lot of young engineers, there are a lot of young people. Most of our population is under 35 years of age. And if this young force does learns semiconductor skills and does these jobs in a good right way, and create the right set of skills, we can create our own Nvidias and Intels right in our own country. This is our responsibility. Like one of I'm really excited by it, and I'm an educator, so this is our responsibility to kind of teach students like you, people like you, to join this industry. And there are people, as in coming few years we'll see people developing their own products, doing their startups, not only just in softwares like Swiggy, but probably in semiconductor as well. Okay, so let's talk about, as in a few things. As in we talked about the ecosystem. So we there are design companies that those are with fab. which they have their own manufacturing. So we have those kind of companies, those are which exist in the ecosystem. Then we have design companies which are fabless. I talked about Nvidia is one such example, which is a very big company. Then you have foundry and fabs like manufacturing, like TSMC. Then you have IP vendor. There are companies which provide IPs which other people use. For example, Synopsys is nowadays a big IP vendor. Then there are EDA companies. There are tools and softwares these companies develop. For example, Synopsys, Mentor. You have Cadence, which develop the software to be used by these companies. And then you have design services companies. There are a lot of design services companies which basically as in help provide resources to for the all these companies to do their job as well. So that's another. India is a big player in design services, not only in software but also in semiconductor. You have system design companies who work at the system level. Then you have software companies. So each hardware comes with their own software, right? Your phone, cell phone, just hardware it's nothing, you need software as well. So there are a lot of software engineers job also in semiconductor ecosystem. These are the multiple kind of jobs which exist in our industry. One is for RTL design. There is IP, RTL development, SoC development, then static checks and verification, synthesis, DFT. These are some of the key terms you would hear about. Equivalence checking, sign off checks. So these are the roles in front end and what is known as RTL designs. Then their role in back-end design or implementation, the activities which are involved are floor planning, partitioning, placement, CTS, routing, sign-off check. So these are the multiple roles which exist in the back end, and people do these roles. There is role both on the software side as well. There not only software side job or in hardware companies, there is something on electronic design automation. These are the companies that produce software for hardware design. There is R&D engineer, product validation engineer, product engineer, application engineer. Then there's sales and marketing. So there are multiple kind of jobs which exist in hardware and software companies. So basically, there are both hardware and software job. There is usually a misconception that hardware means a hardware job. There is both software and hardware jobs in this industry, and hardware is not hard. Let's say you have same way you're writing a Python code. Most of the time, you will be writing some code on your computer, even for an hardware design. So there are plenty of jobs, as in India is supposed to create 1.25 lakh jobs in next 5 years. That's purely in design. And if you compare it with the IT industry, the average starting salaries in multinational companies is around, it varies from 8 to 20 lakhs. Even in services companies, as in once you complete your internship, the packages are really good compared to IT industry. So if you are an electronics engineer, if you are an EC engineer, think about joining this. There are multiple ways of joining this, as in if you're in right now in college, start taking those courses which are important for they're not like, it's not that you have to take hundreds of courses. There are just 4 or 5 courses. If you can take, you can get a good job in semiconductor industries. We have a website, www.vlsideepdive.com, where we have a lot of courses. If you are someone who's looking to learn more in VLSI, you can go to these courses. We have workshops, we have video courses like Udemy, we have boot camps. So we take care of all the teaching learning needs, even whether you're in college or working professionals. We do have a free YouTube channel. You can go to www.youtube.com/VLSI deep dive. At VLSI deep dive, you will see a lot of free videos posted there as well. And this session also, once recorded, will be posted on YouTube. So think about, as any, no matter you're a software engineer, you are a hardware engineer, semiconductor engineer, do think about joining this industry. There are a lot of opportunities and higher salaries which are coming up. Okay, so let me see if there are any questions you guys want to ask. Post it in the chat window, and I'll be very happy to answer those questions. And the questions can be anything related to jobs, semiconductor industry. Please type your questions in the window, and I'll take those questions now. Please type your questions in the chat window if you have any. Okay, it seems like there are no more questions. So this is what I wanted to talk about. If you have any questions, type it in the chat window. Otherwise, this is what I wanted to talk about in today's session. There are multiple opportunities there, so please join this industry. If you need any guidance, any help, we at VLSI Deep Dive do provide free mentoring also. So you can reach out to us on our website. There is a WhatsApp link, and we'll be very happy to answer your questions there as well. So there is a question, sir. How does a BTech student get an internship in VLSI? So one of the important and some of the important thing is when you're looking for an internship, there are multiple companies basically which are providing internships. So we can also help you in getting an internship. As in, one of the important thing is some of the top companies do look out for your CGPA or percentage. So don't as in take care of your percentage and CGPA. Don't waste your time and lose out on percentage and CGPA. So what that is one of the way. As in, if your percentage is good, you will be able to get internship. And if you need any help in internship, do reach out to me on www.vlsideepdive.com. So there is a question: how much of our academics and college matters? It matters, as in there are a lot of companies who shortlist based upon percentage. So it matters. Don't just think it doesn't matter. Once you're in college and you automatically get a job. But as in, if you even if you're not able to do good in 1 or 2 semesters, then as in there's still opportunities out there, but you'll have to kind of adjust your opportunity. So percentage and CGPA is important. There is a question: difference between analog design engineers and analog layout design engineers. Analog layout design engineers basically are more in memory. They do layout design, but analog design engineers is design, like for example, some of the RF circuits and design those circuits. Yeah, so there is a slight difference. Analog design engineers requires much more mathematical on electronics, like if you electronics background. Layout engineers is more about layout, creating a layout for standard cells or analog designs. So it's slightly different job, but as in if you have done your fundamentals well, you can convert from one job to another. Any other questions? Any one of you have? Please feel free to type it in the chat window. So there is a question: currently openings of fresher is less, more openings available for 3+ experience. When will hiring start for internship positions? So you're right, as in we are going through a recession, so opportunities are less, but there are opportunities out there. As in, if you have done your training well, there are a lot of new startups also which are hiring. There are services company also hiring. So if you have done your taken care of your fundamentals well, you still be able to get opportunities. And if you need any help, as I said, right, you can reach out to vlsideepdive.com. And probably, as in my guess is early next year is when market will open more. But right now there is a good situation. Okay, so there is a question that I have completed DFT training now and there are no vacancies. So actually DFT, there are a lot of opportunities. So if you're not able to find opportunities, do reach out to us, vlsideepdive.com. We'll help you out. Okay, there'll be a WhatsApp link. You can click there and we can help you out. Any other questions? Please feel free to type it in the chat window. So WhatsApp link, you go to website www.vlsideepdive.com. You will see the WhatsApp link here. So there is someone named Faiz, and he has worked in physical design for almost a year, but now the unavailability of project. So how he, as in he's looking for guidance. So what I would suggest is, if there is unavailability of project, what you should do is you should upskill yourself. There are both in backend physical design and STA. There are a lot of courses which are available, and some of these courses actually take you through real project work. So don't stand still. Start looking for other opportunities, and also basically start upskilling yourself by multiple. As in, you can learn for free on YouTube. You can learn You can learn for other areas as well. So there is a question: VLSI job role, their vacancy is maximum. Right now, there are a lot of opportunities in design verification. There is a lot of opportunities in DFT. If you have specialized skill like PCI, PXL, these kind of areas, again, there are a lot of opportunities as well. But in general, uh, verification is usually there are a lot of jobs always, and physical design used to be that field, but right now, in my opinion, there is a lot of supply. So there is a question: VLSI companies are offering jobs for 3 to 5 lakh. What's your view on that? So basically, right, if you look at MNCs, typically their job will start from 8 to 9 lakhs, but services companies' job will start from 3 to 5 lakh. And what I would suggest is you pick the best opportunity you are getting, and don't wait. Okay, I will wait for 1 year and get better opportunity, because in VLSI, one of the important thing which happens is your salary grow at a very high rate. It's not a linear rate. So even if you, let's say, you start working at a lower salary in first 1 year or 2 years, the skills you gain will help you grow more than the initial salary. So do focus on that. Whatever the best opportunity you are getting, take that. There is a question: company mass fired. Right now, I am upskilling but not getting any job opportunities. I understand the pain you are going through, but please keep in mind this industry is going to grow. So just give yourself little bit of time, and you'll find the right opportunity. Any other questions? Please feel free to type. Okay, so some insights about SOC design role. So SOC design role, one is architectural level role, which you get after you have some at least 5 to 10 years of experience. There is SOC connectivity role, there is SOC verification role. So multiple roles exist. There is SOC verification also. There is hardware software co-verification. The multiple roles even exist at SOC levels. There is a question: without how to handle that situation. I think, yeah, that is an unfortunate situation, but VLSI deep dive can help you with the referrals. So do join or go to our website www.vlsideepdive.com, and there's a WhatsApp link. Click there. We'll try to help you from our side as much as we can. Validation engineer, is it good job in VLSI for future perspective? So there are two kind of roles. There is one is verification engineer. Verification engineer is you do verification. Validation engineer is when you do hardware validation. Both have good opportunities. It depends on your liking, which work you like more. If you're liking your work, then there is a lot of good opportunities in each of the semiconductor areas. Is there any role in SOC design for fresher? So typically it will take you few years before you start contributing more on SOC design. Probably RTL integration or SOC integration is one of the areas where fresher can help out. But typically, how a role of the fresher grows in the industry is you typically start from a small, and then basically once you gain experience, people start giving you more role. So don't get hung up on, okay, this is the only thing I want to do. Get into a good role initially, good company, and then your role will grow. That's what I would suggest.